everyone, this is Michael. I wanted to walk you through a Rails TypeScript project I had put together for a maze game. Let's take a look. So this is a traditional get to the end walk through a maze things with a few added features, most notably this key cell system. So if you notice, if I go down here, I'm not allowed to move through these red blocks. To do that, I have to first have passed through the corresponding key with the color. So this red key will now allow me to move through the red blocks. Same thing for each other color. You'll notice none of these I can move through until I unlock their color. And then here is the other type of special cell I designed. It's ice to simulate a slippery surface. Once you move onto it, you'll continue to move in that direction until you're stopped. And then here you'll see I've got to the end. So the other thing we have here is built-in pathfinding algorithms. And the interesting thing in this case is for a usual, say, breadth first search, what you're doing is you're saying, okay, I'm going to move through this graph, the maze you can think of like a graph, and I'm going to keep track of nodes I've already been to. And when we go back to a node we've already been to, we're going to say we're not going to continue through that path. We've already been there. We know it's not part of our shortest path. The difference here is that the state of the puzzle changes every time you unlock a new key. So you can't say in this system, oh, I've already been to here, now I can disallow paths that go down there. What would happen is if you did that here, this puzzle wouldn't be solvable, because what it's going to do is it's going to first go through this path, going to see it can't get through here at all, and then after having ran through the red key, it's going to go back. And the way around this is to, instead of recording that just for each node if you've been there, for each node you record if you've been there for each combination of state changes or keys you've unlocked. And you'll see that in the pathfinding algorithm by a change in color of the path that gets highlighted. So let me demonstrate that for you here. Okay, you'll see that kind of light green from red, and then you'll notice what's happening here is it's taking a lot longer to do anything. Well, that's because we essentially have about 8 different paths going based on the number of keys we've unlocked. It's got 8 times as many paths to roll through. You can see by all the different color combinations on these squares, the dark blue, the orange, the more green, the lighter green, which was just the red being unlocked, kind of showing what's been unlocked. This is where some of the more advanced algorithms coming in, like the A-star search here. What this is going to do is this is going to prioritize paths closer to the finish. You'll see when we run this, once it gets to here, it kind of just focuses on this top part and goes straight for the finish. As opposed to earlier when we got down here, it would go out in every direction, and there would be a bunch of different states unlocked that it would have to account for. So there's a lot of pre-built levels here, you'll see, and kind of just different designs for puzzles. And the other thing there is that I built in is a level editor. So you want to make your own puzzle, you come in here, you put in a finish, you put in a start, and then you can build whatever you want. And this is cool because it's kind of similar to a usual pathfinding algorithm program where you're essentially building the maze and you're testing the algorithms on the maze. The cool thing about what I built is that there's some special squares which make it a little more interesting, and there's the pre-built levels to kind of make it feel like a more traditional game that you could use as an app, right? It's got that dual use. Thank you for watching, and goodbye.